Hi everyone! In this video, we're going to go ahead and talk about the most important periodic table families. And periodic table families are helpful because they let us know how elements tend to behave because we group them with other elements that have similar properties. So let's go ahead and get started. Okay, so the first family is the alkali metals. So this is column 1 or group 1 of the periodic table, except for hydrogen. Hydrogen is not considered part of the alkali metal family because hydrogen is a nonmetal, so it's not going to be part of that group. So this is lithium all the way down to francium. And these elements are known for being very reactive, especially with water. And I actually have a really fun video to share with you, so make sure you watch that as well. And as we go down the periodic table, the elements become more reactive. So lithium's a little reactive, sodium's more reactive, potassium's even more, and we get down to francium and it is super reactive. Also, as you look at these elements, they tend to be very soft. You can just cut them with a knife, which if you think about it, taking a metal and cutting it with a knife doesn't sound feasible, but it is. They also have very low densities. Many of these will float on top of water. They have low melting points and low boiling points compared to other metals. And all of these family members have one valence electron because they are in group 1. Okay, the next family is the alkaline earth metals. And we have to be careful because alkali metals and alkaline earth metals have kind of similar names and they can get easy to be mixed up. So the way that I remember it, alkali is just one word, so it's group 1. Alkaline earth is 2 words, so it is group 2. So hopefully that helps you as well. So this is all of group 2 or column 2, so beryllium all the way down to radium. These elements are reactive, but not as reactive as the alkali metals. They tend to be shiny, kind of silvery white in color, and they all have 2 valence electrons. Moving across, the next group is the transition metals. This is a whole big group of elements. They all have kind of unique properties. This is groups 3 through 12. Most of these elements are ductile, meaning we can draw them into a wire, so things like silver and gold. That's why a lot of these make great metals for jewelry. They're malleable, meaning we can hit them with a hammer and form thin sheets of them. They also conduct electricity and heat very well, which makes them great for wiring in our houses or electrical devices, and also when we use them for cooking to transfer that heat to our food. And these all tend to have high melting points and boiling points for metals. Now, one important thing with the transition metals is the number of valence electrons they have will vary. So because of that, I will never ask you how many valence electrons these elements have. Okay, the next group is the halogens. We're moving all the way almost to the far right of the periodic table. This is group 17. And this is everything column 17 from fluorine down to tennessine. These elements are very reactive, just like the alkali metals are very reactive. And they all have 7 valence electrons. Although, fun fact, the reactivity is actually higher when you go up on the periodic table for the halogen. So fluorine is the most reactive halogen. And then finally, we have the noble gases. So these are the group 18 elements, the last ones on the periodic table. So helium all the way down to one of our newest elements, oganesson. These elements are all extremely unreactive, meaning that they almost never form bonds with other elements or with themselves. This is why for many years we didn't even know the noble gases existed. When Mendeleev made his periodic table, he didn't leave a spot for the noble gases because we had no clue at that point in time that these elements would be on our planet. So all of the noble gases have 8 valence electrons, except for helium, because helium is so small, it only has 2 valence electrons, which fills up that inner ring for period 1. And then just a fun fact for these, noble gases actually comes from the idea that nobility, back in kind of medieval times, would separate themselves off from the rest of the common elements. And just like the noble gases don't want to react with anyone else, they kind of stay separate from everyone else. So thanks for watching. I hope this helps. If you have any questions, please let me know. Thanks, everyone. Bye.